Hello and welcome back to computer programming. All right, so we're going to be continuing on with 2D arrays, and you're going to be using them to create a tiny little tic-tac-toe game. So you're going to find out that the code for it isn't that tiny after all. Whoops. All right, so start by downloading the file. All right, so open a new window, download, bring up my downloads folder, extract all. Okay. So I'm going to delete that. I'm going to drag that into computer programming. And then let's take a look at what's actually inside of here. All right. So inside of here is some code to get you started on this tic-tac-toe program. It's also here to show you how to send 2D arrays to a function. All right, so much like one-dimensional arrays, when you send a 2D array to a function, it is going to be by reference. So any changes you make to that array inside of the function will change the array sort of globally, if you will, up in the main as well. Now, really, the only other thing that you need to know is that when you're passing it to a function, you leave the row brackets blank to designate that it's a 2D array, but you do have to specify the number of columns in the 2D array. So when we were sending one-dimensional arrays, it was just blank brackets. That's how we designated that our function was receiving an array. When it's a 2D array, there's still blank brackets, but then you do have to provide the column number. So if you decide to use functions for certain parts of this program, and believe me, they're useful, when you're sending the 2D array into the function, you send it with the double brackets. The first bracket is empty. The second bracket has to specify the number. And for a tic-tac-toe game, it's always going to be 3 columns. All right. So right below here, you will have here's a 2D array of characters. And it just has 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how the user is going to know which box they want to pick. The boxes are going to be entered 0 through 9. This is a variable just to keep track of whether the game is still going or not. So when the game is active, the variable is 0. When the game is over, it can be anything other than 0. And this right here is a function that I've already written. Right? It's down below. And this takes care of printing out and formatting the board. All right, so you don't have to worry about formatting or printing out the board. This will do it automatically. And then this is the loop right here that can just keep your game running. So while game is 0, it keeps going. When it eventually ends, you set this to 1, and that will exit the loop and allow you to leave the program. So if I run this really quickly, you'll see just what the printed out board looks like. All right, so there's the printed out board. The user is going to pick a number 1 through 9. You're going to put their mark on the screen, whether that be an X or an O, and then you're going to check to see if there's a winner. All right, so the program has to be able to figure out whether there's a winner or a loser, and then inform the user that either the game is over or that it's player 2's turn or player 1's turn or so on and so forth. All right, so if we bring up the lab document really quick, it kind of runs you through the main things that you need to do. All right, so some things you need to consider when writing your code. All right, the marks are going to need to alternate between X's and O's. So it's 2 humans playing the game. It's not like a human versus the computer. It's 2 humans playing the game. So they're just going to kind of share the keyboard. But you have to make sure that the marks alternate between X's and O's. So, you can have first player be an X, you can have second player be an O, but then it has to keep rotating back and forth there. The second part says, the code you wrote to add rows, columns, and diagonals will be useful for checking for winners. All right, now here's how I want you to do this for this lab. There might be other ways to do it, but this is how we're going to do it in this lab. All right, we're basically going to create a second array. All right, we're going to say int, we can call this, what do we want to call it? We'll call it Tic Tac Toe. Why not? All right, it's going to be the same size as the character array. And at the start, it's going to be empty. Everything's going to have a 0 in it. Now, the way that your program needs to work is that when somebody selects a square, all right, let's say they select square 1 and they want to put their mark there, right? In the character array, you're going to change that 1 to either an X or an O. In this tic-tac-toe array, you have to pick a number that goes with X and you have to pick a number that goes with O. So, for example, I could say that anytime an X makes a move, I'm going to put a 3 into this array. Anytime that O makes a move, I'm going to put a 7 into the array. All right, so you basically got two arrays, one with the characters, all right, X's, O's, and these numbers, and then one that's purely numeric, all right, that's going to have, again, you can use different numbers, but let's just say 3 and 7. All right, now the purpose of this second array is it's always going to match this one, all right, but we're going to use this second array to actually figure out when there's a winner and a loser. All right, you're effectively going to use the same code that you wrote in the last lab to find the sum of a row. All right, now if the sum of the row is 9, you know that X won. If the sum of the row is 21, you know that O won, because again, those numbers correspond to the X's and the O's. And then you'll do the same thing for the diagonals. If you have a diagonal that adds to 9 or 21, if you have a column that adds to 9 or 21, and you don't have to choose 3 and 7, but you do have to pick ones that don't overlap. So here's what I mean. Like, you wouldn't want to choose 2 and 4, all right? Because if you chose 2 and 4, all right, you could either have a sum of 6 because you had 3 2's, or you could have a sum of 6 because you had a 2 and a 4, and you wouldn't be able to tell the difference just looking at this integer array. So you can pick whatever numbers you want for the X and O. There just can't be any overlap, all right? And that's what this lab document is referring to when it says the code you wrote to add rows, columns, and diagonals will be useful for checking for winners. So you're going to have this basically hidden array that the user never sees that's filled with numbers, and you're going to keep calculating sums on those different numbers to check for winners. All right. You're also going to need code to check to make sure that they don't try to place their mark in a spot that's already taken. So, if X takes the center square and then O tries to take it again, you have to give them a little message or at least make them pick a new spot. All right. They can't overwrite what somebody already did. If the board is filled and there is no winner, you should print out some sort of draw message. Just a quick note, the array is of type character because we need to be able to put X's and O's in it, so we can't have it as integers. But that means if you're doing like an if statement, you're going to have to use the equal signs. I don't know why there's not two equal signs there, but it's going to be like if play equals equals and then single quotes around the 1 because it's a character 1. It's not a numeric 1. All right, and then if you get everything else working, you can consider adding an option so that the players can keep playing if they so choose. So like if they lose the game and they want to play again, you could give them an option to say play again if they so chose. All right, so that's effectively what you're doing. You're creating a C++ tic-tac-toe game. Now, a couple of things I will say, when you're having the user pick the square, there's generally two ways that students do it. One is you can just do if statements, like if they choose 1, put it in spot 0, 0. If they choose 2, put it in spot 0, 1. If they choose 3, put it in spot 0, 2. And you can have 9 if statements that check the 9 different possibilities that they could type in. There's also a calculation. right? And I'm not going to tell you what the calculation is. I'll just say that, it involves like division and remainders, that if you figure out the calculation, you can just take the number that they type in, perform this calculation, and get the coordinates of the box. And then you don't have to write 9 different if statements. Again, it's probably going to take a little time to figure out what the calculation would be. But if you're able to figure it out, it does save a lot of time because then you don't have to write separate if statements for each of those. Right? But that's the general idea. Like, I don't want to give you too much because I want you to try to kind of explore it on your own, and I want you to try to figure it out on your own. But that's the general kind of idea. You're creating a tic-tac-toe game in C++. All right, you're going to have these two 2D arrays. One is sort of the visual array that the user sees, and it's type character. And then the second one is going to be an integer array that sort of operates behind the scenes. And you're going to use that to calculate all sorts of sums to kind of check for winners, check for losers, and so on and so forth. It's up to you how you want to break the program down. All right. I think it would be helpful to write like a separate function whose only job is to check for winners and losers. But that's up to you. You could write a function that just handles like figuring out where they placed their mark. I'm really kind of at this point in the course, you've done a lot of programming, you have a lot of experience. I want you to sort of structure this and kind of make it your own. But within this framework of sort of a functioning tic-tac-toe game. Now, let me just show you really quickly sort of what mine looks like. Give me a second here. All right, so here's mine. Again, it just says X choose a square. If I do a 1, you're going to see that it then prints the board out again, and X is now in the top left corner. It then lets O choose a square. So let's say O takes the center square. It then prints out the board again. It's showing me the update. O is in the center square, X is in the top left. If I try to choose a number that's already taken, mine doesn't give an error message. It just forces them to pick again. So I'll pick 4 this time. Then I'll have O pick 2. And then I'll have X pick 7. And again, it's then able to detect that X wins, and it prints out a little message. And then mine asks whether you want to play again or not. You don't have to do that, but it is an optional feature that you can add to it. So if I want to play again, it then prints out a full board, a clean board. And then let me just show you the draw so that you can see that it does need to be able to detect when something like that happens. We'll put, did I goof up? Did I make it so that somebody's going to have to win? I think I did. No. Congrats, X wins. I can't even lose when I try. All right, let me do this again once more really quick. All right, we'll have X go there, we'll have O go there, we'll have X go there, we'll have O go there, and then X will block, and then O will block, and then X will block, and then O, I don't think can win anymore. So I think we're safe now. All right. All right, and then mine just says, congrats, you both lose, and then do you want to play again? So that's generally what it needs to be able to do. It needs to be able to detect when somebody wins. It needs to be able to detect if the game ends in a draw. You can add this option whether they want to play again or not. But all in this framework of sort of working with a 2D array. One that's sort of the visual array that's being printed out to the screen, and then a second one that operates behind the scenes, storing various numbers that you're calculating sums on to detect, winners, losers, and so on and so forth. All right, so I hope this was helpful. Let me know if you have any questions, and best of luck. All right, have a great day. Bye.